Let's first proceed with molarity. So what is molarity? Molarity or molar concentration simply talks about the amount of substance or solute that is contained in a 1 liter of solution. The unit of measurement for molarity is mole over liters. And, and the formula that we are going to use for this is molarity is equals to moles of solute divided by liters of solution. So from the formula itself, okay, we are looking for the amount of solute that we have in a liter of solution. Let's proceed with our practice problems for us to familiarize much better with molarity. For the first problem, we have here what is the molarity of a 1.5 liter solution containing a 0.029 moles of sodium hydroxide. So for the given, we have 1.5 liters of solution and it has a solute, okay, with 0.29 moles of sodium hydroxide, or what we call the NaOH. Again, the formula for molarity, we have to go back to the slide a while ago. Molarity is equals to the moles. Molarity is equals to the moles, okay, of the solute divided by the liters of the solution. So let's try to solve it. So we have 0.029 moles of NaOH. We have to divide it by the liter of solution, which is 1.5 liters. Our answer here would be 0.0193 moles per liter of NaOH. This is now our final answer. This is how easy solving for molarity is. Okay? Let us now proceed with our next problem. We have here 2.3 moles of potassium nitrate are dissolved in enough water to give 650 ml of solution. Calculate the molarity of the solution. So we have our givens, which are 2.31 moles of potassium nitrate, and we have 650 ml of solution. So for our formula again, for molarity, we will be dividing moles over liters. Okay, let's do it. We have molarity, right, the given, which is 2.31 moles of KNO3 or potassium nitrate, which you will divide it with the liters of the solution. But as seen in our given, we have here milliliter. Okay, so what we need to do is we need to convert 650 ml to liter. Okay, so what is the equivalent of liters to ml? So we have 1 liter is equals to 1,000 milliliters. So we have 650 ml. We have to multiply it by 1 liter over 1,000. Okay, and then you will be getting the answer of 0.65 liters. This is what you will be using as a given for liters in our equation. So you simply put it 0.65 liters, and then you proceed with solving. To divide 2.31 moles of potassium nitrate divided by 0.65 liters, you will be getting 3.55 moles per liter. This is now your final answer. Right? Again, if your given is not in liters, you have to convert it first. For our third problem, we have here what is the molarity of a 25 grams of calcium hydroxide dissolved in enough water to give 25 ml of solution. So for this one, we have to write what are the given first. So we have to write the given. First, we have 25 grams of calcium hydroxide. So simply write it, 25 grams of calcium hydroxide. And then we have our 750 ml of solution. With our formula, which is molarity is equals to mole divided by liters, okay? None of our given follow the units of measurement used in the formula. So we have to convert them first. First, we have to transform ml to liters. So again, conversion unit 1 ml, again, conversion unit 1 liter is equals to 1000 ml. So all you need to do is multiply 750 ml times 1 liter over 1000 ml. Then you will be getting 0.75 liters. Okay? And then for our grams or for our molarity, we have to convert it first to moles. In order to convert it to moles, we have to multiply 25 grams of calcium hydroxide by the molar mass of our given compound. But in our problem, molar mass is not given. So we have to solve for this one first. So how do we solve for our molar mass? Again, we just need to list down the given elements in our compound. So we have your calcium, oxygen, and hydrogen. So for calcium, let's look at the atomic mass of calcium. We have here 40.08 and then multiply it with the amount of calcium found in the compound, and that's just 1. For oxygen, we have 16. Multiply it with the amount of oxygen in the compound, so we have 2. For hydrogen, it's 1.008. Multiply it with the amount of hydrogen in our compound, and that is also 2. Using your calculator, try to solve for all of this, and then simply add them. Our molar mass now for calcium hydroxide is 74.096 grams per mole. Let's now multiply it with our given. So we have here 25 grams of calcium hydroxide, multiply it by 1 mole of calcium hydroxide divided by the given molar mass, which is 74.096 grams. When you proceed with solving, we will be getting a total of moles of 0.337400129 moles of calcium hydroxide. Of course, all of these numbers, we should round them off to two significant numbers. So our final mole will be 0.34 moles of calcium hydroxide. You can now proceed with solving for the molarity of our solution. Again, our formula for molarity is equals to moles divided by liters of the solution. So if you were to write out 0.34 moles, and we have to divide it by our given liters of solution, which is 0.75 liters. Our final answer here should be 0.449866,839, or if you were to round it off to two significant numbers, we have 0.45 moles per liter. So this is now your final answer. Okay, so you have to analyze the problem first. You have to look for what are the given and then you have to follow the units given in the formula. So you have to solve and convert molar mass if needed. Let's now proceed with the final part of our discussion for the part 3 of module 3, which is about dilution. Dilution may also talk about the concentration of a solution. So this is the process in which more solvent is added to a solution in order to lower the concentration of our given substance. So for this one, we will be using the formula C1V1 is equals to C2V2, wherein C1 is the concentration of the stock solution, V1 is the volume of the stock solution, C2 is the concentration of the diluted solution, and V2 is the volume of the diluted solution or the new solution. Let's try to answer these sample questions or sample problems in order to familiarize ourselves with the solving part. For the first problem, we have here a medical technologist prepared a 5 mole sodium chloride solution from a 500 ml of 10 mole stock solution of sodium chloride. Determine the volume of the diluted solution. For our first step, we have to identify first and analyze our given problem for us to easily identify what are the given. So let's identify which are the C1, B1, C2, and B2 with our problem. For our first given, for C1 or the stock solution, we have here 10 moles of the stock solution of NaCN. So we have the 10 moles of NaCN. For the volume of the stock solution, we have 500 ml. For the concentration of our diluted solution, we have 5 moles of sodium chloride. And then we are looking for the volume of the diluted solution. So this is what we're looking for. Then we will be using the formula C1V1 is equals to C2V2. So just substitute the given. So for the concentration or for C1, we have 10 moles. Multiply it by 500 ml. Then for C2, we have 5 moles. Then we're looking for the V2. Okay, simply multiply 10 ml by 500. So we have 5,000 moles per ml. And we have here 5 moles. And since we're still looking for V2. And then you have to divide both sides by 5 moles because we are only looking for the volume 2. So we have here, let's just switch their places. Volume 2 is equals to, kindly compute this on your scientific calculator. You will be arriving at our final answer, which is 1000 ml. This is now your final answer for our first problem. Quite easy, right? There's also another method for us to use in solving for our diluted solution. So for the other method, you can immediately transpose, okay, the given formula. So instead of using C1V1 is equals to C2V2, you can transpose it. Since we are looking for the volume of the diluted solution, it has to be alone on the other side. So you can divide both sides by C2. So our new formula now will be V2 is equals to C1V1 divided by C2. And then you can proceed with substituting the values. So you have V2 is equals to C1, which is 10 or 10 moles. V1 is 500 ml. Divide all of them by 5 moles. And then you will be arriving with the same answer, which is 1000 ml. Okay? It does not matter whichever method or whichever way you prefer, you will still be arriving at the same solution. So just use whichever you're comfortable to use. For our next problem, we have here what is the molarity of the solution prepared by diluting 2.75 liters of 0.85 moles of hydrochloric acid solution to a final volume of 1.50 liters. So again, analyze the problem so that we can simply identify the quantities in our solution or in our given problem. So let's identify which is the C1, B1, C2, and B2. So for the concentration of the stock solution, we have here 0.5, 0.85 moles of HCl. For the volume, we have here 2.75 liters. Then for the concentration of the diluted solution, that is what we are looking for. We are looking for the molarity, okay, of the final solution. And then for the final volume, we have here the given 1.5 liters. Let's write our formula. We have C1V1 is equals to C2V2. Let's try it first with our first method. So again, substitute the formula with the given quantity. For C1, we have 0.85 moles of HCl. Moles. Then we multiply it by the volume 1, which is 2.75 liters. Equals to C2, which is what we're looking for. And then multiplied it by the final volume, which is 1.50 liters. Okay, and then proceed. 0.85 moles times 2.75 is 2.3375. Okay. Then we have here C2, 1.50 liters. Then you simply divide both sides by 1.5 liters because that's what we have to remove. And then our final answer will be concentration 2 or concentration of the diluted solution is 1.5583 moles. This is now our final answer. Okay, let's try it with our other method. So in our other method, you have to transpose the formula immediately. So instead of using C1V1 is equals to C2V2, okay, you already transposed it. So since we're looking for C2, it does not has to have a companion on the other side. So you divide both sides again by V2. Cancel this one. So we have now C2 is equals to C1V1 divided by V2. And then transpose or substitute the given quantities. We have C2 is equals to C1, which is 0.85 moles. Multiply it by the volume, which is 2.75 liters. And then divide all of it by 1.50 liters. Then your final answer, try to do it on your own using the scientific calculator. You will still be arriving at the final answer, which is 1.5583 moles. You can see, still arrived at the same answer. That's how easy it is. We are now done with the discussion of our Module 3. So we've already discussed all of these three parts: chemical equations, chemical calculations, and solutions. So hopefully you all already finished the practice test that will serve as a preparation for you in your upcoming quizzes. Here are some of the references that you can use so that you can read much further about our given topics. Thank you and God bless.